Scientists have always had difficult doubts. Space before the birth of our universe. What does it look like? But this problem has surpassed our current, the time frame as understood by science. Because, according to observations of the cosmic microwave background radiation, scientists believe that about 14 billion years ago, the universe was born at a pole, its intense bombings. This event is known as the Big Bang. Before the Big Bang, nothing exists in the universe. But our current scientific theories fail to explain the early state of the universe. Assumed by scientists before the Big Bang, nothing. No substance, no light, no power. There's not even space or time. This moment is called nothingness. With the sudden emergence of the universe, it starts to swell. To this day, our universe is still expanding. But the rate at which the universe is expanding is not set in stone. It's accelerating. Between objects, they're moving away from each other faster and faster. This hairstyle also led to the concept of dark energy. Is used to explain this phenomenon of accelerated expansion. Today, we will uncover the mystery from a scientific perspective, since the universe at some point, born from nothingness. Then will the universe finally will come back to a similar, in a state of nothingness. What is nothingness? First, scientists predict that all matter in the universe will eventually disappear. The universe will come to an end. Some of the latest studies, more disturbing. Objects begin to gradually disappear in the void. Stephen Hawking once mentioned, this will be one of the reasons why the universe is coming to an end. Astrophysicist at Rad University in the Netherlands, Michael van Drak, Walter van Zijlikum, and Hannah Falk pointed out that every massive object are slowly disappearing into space. This could be a sign that the universe is coming to an end. What's going on in the universe? We need to know Hawking's views on radiation and the demise of black holes in theoretical physics, a fascinating topic. In the 1970s, famous physicist Stephen Firegold proposed a revolutionary idea, challenged our understanding of black holes. This theory is known as Hawking radiation. He pointed out that black holes are not completely black. It emits faint radiation. This gradually makes them lose quality, eventually evaporates over extremely long time scales. To understand Hawking radiation, we need divine help to understand the properties of black holes. A black hole is an extremely attractive force in space. Hardly any object able to escape their attraction. That includes light. According to classical physics, once an object travels through the world, it means that he has entered the interior of the black hole. Nothing more can escape the attractive force of a black hole. The world is an imagined boundary on the surface of a black hole. Once crossed, it is equivalent to crossing the irreversible point of the black hole. Means the escape has been lost. The possibility of black holes. And what was innovative about Stephen Hawking is that he combined two well-established scientific theories, put it together. These two theories, quantum mechanics and general relativity, This combination means he tries connecting theoretical ideas in these two fields to explore the behavior of the universe and matter. Quantum mechanics describes the microscopic behavior of particles, and general relativity explains the attractive force and the curvature of spacetime. However, the two theories initially seemed incompatible. Quantum mechanical suggestion space filled with virtual particle teams. They keep showing up, and small teachers usually cancel each other out. However, Hawking realized that near the earthly world of black holes, one of a pair of particles could fall into a black hole, and the other will escape. The energy generated by this phenomenon borrowed from the attractive force field of a black hole. The resulting black hole loses a little bit of mass. This is known as Hawking radiation, similar to a black hole gradually disappearing. This process occurs at a pole. On a long time scale, smaller black hole radiation is lost faster. For example, a black hole with the same mass as the Sun, it takes about 67 powers. That's 100 trillion billion years to completely evaporate them. This is well beyond the lifetime of the universe. As black holes lose their treatment, it gets hotter and hotter. Police officers normally think of black holes as being very cold. This situation, it may be related to our cold impression of black holes. Contradiction. However, the temperature we are referring to here refers to the emission from a black hole temperature of radiant energy, rather than the temperature of the black hole's body. When a black hole loses mass, he emits radiation at a higher temperature. This means that the intensity of radiation will also continue to increase. So even though the black hole itself doesn't get hot, but he emits energy at a higher temperature. This is a characteristic of black hole radiation. At the same time, the latest research reveals that, or this particular form of radiation, not limited to black holes, other objects also have this phenomenon. In fact, studies have shown that all kinds of objects in the universe may emit Hawking-like radiation. It's not just black holes. This suggests that the universe appears to be gradually losing mass. It's like things are evaporating. The existence of this radiation phenomenon indicates that all objects in the universe are in some kind of degree of loss of quality. This is essential for our understanding of the transformation of the universe, and the future are of great significance, except for black holes. Area of spacetime, when generating radiation similar to Hawking radiation, plays an important role. Where there is an extremely attractive force field, this attractive force field generates tidal forces. Tidal forces affect the behavior of particles, cause them to separate from each other. Specifically, tidal forces are due to the attractive force field on objects due to the different strengths of different parts. This causes the object to be stretched, or the effect of compression. In extremely attractive forces, this tidal force can cause particles to separate. This is all possible with Hawking, the phenomenon of radiation. Massive object, such as the planets in the solar system. It can also be out of control around it, to zigzag or bend. When the air rate occurs, he will affect the quantum field in it, and that leads to something like Hawking radiation. Therefore, objects that have no practical world, like dead stars, remnants left behind, and other large objects in the universe. It also produces radiation similar to Hawking radiation. After a long time, this radiation will result in the universe. Everything gradually loses its quality. It's like a black hole. So this discovery not only changes our views on Hawking radiation, it also changed our understanding of the universe, understanding of its future. The study shocked astronomers because they generally believed that only black holes lose mass in this way, gradually disappear into the void. But this new study expands our horizons. Let's understand that it's not just black holes. All large objects in the universe will gradually disappear before our eyes. Loss of mass in the form of Hawking radiation. Just as the universe began with the Big Bang, he will one day come to an end. However, we do not yet know the end of the universe. What will it be like? This amazing discovery, perhaps it will be a cause of the end of the universe. Many theoretical physicists believe that the end of the universe may be in the next 2.8 billion years, happen within 22 billion years. Some researchers even suggest that this process may have already begun. So what will the future of the universe look like? His expansion rate. Eventually, it may cause itself to fall apart, cause a huge disintegration. Another possibility is that the universe will contract, shrinking or gradual collapse, reverse the Big Bang, ultimately destroy the entire universe. The third theory is called the Great Winter Festival. He assumed that the universe would expand forever. Ultimately, all matter achieve a completely uniform state. Therefore, according to this new discovery, massive objects in the universe will gradually lose quality. It's like a black hole. This is achieved through Hawking radiation. Eventually, enough gas will accumulate in the universe. Dust and compact matter, soon to regenerate new stars. Make the universe shine again. The rest of the universe will be made of black holes and other things. But they won't have access to new substances because there is nothing to nourish them. Black holes slowly emit radiation, eventually evaporate into nothingness. When we think about the fate of the universe, we are amazed by the beauty of the universe around us. It raises profound questions. The significance of our human existence. From the birth of stars to the infinity of galaxies, we can't help but feel in awe. Because we are starting to realize the complexity and wonders of the universe. What do you think? Will the universe return to a state of nothingness again? If the universe returns to a state of nothingness, and who do you think is out there? Created the universe? Tell your differences in the comments section. Opinions and opinions. Thank you for your patience and attention.